Hello and welcome to this recording. In this recording, I'm gonna go over some firewall related questions, and the goal of this tutorial is to look at how to create firewall rules for different scenarios. So I'm gonna focus on a few things that we discussed in the firewall lectures, including the rule elements, which last time we talked about the generic rule elements that include the base protocol, source address, sometimes the source port, target address, target port, and action. And also, I'm gonna use some scenarios where I introduce direction as well. And we're gonna focus also on making sure that the rules are following the rule ordering guidelines that I mentioned last time. The specific protocols, specific rules should be higher up in the order. We try to make the rules as few as possible, and also I'm gonna assume that we are using a stateful firewall, and we have a universal deny rule at the end. So in all of these cases, another goal of this tutorial is making sure that we don't have any anomalies in the rules. Right, so we're gonna avoid making anomalies, which, to remind you, they are shadowing, correlation, generalization, and redundancy. There are also the irrelevance anomaly, which is, the rule should be relevant to the network. So with that being said, I'm gonna start with some basic scenarios and then we'll progress from there. Okay, so here I'm gonna put side by side the questions, and also in the spreadsheet to the right I'm gonna write the rules just to make it easier. So the questions here ask, or the first question asks, for the simple network in the figure below, how could a packet filtering firewall allow telnet traffic from a specified external network 16.16.16/24 to the internal network, allow HTTP traffic from the internal host to the internet, and prevent any attempt by an outside source to masquerade as an internal host. Assume the following: the firewall allows return traffic, so it's a stateful firewall, stateful packet filter firewall, and also there is a deny all rule implied at the end. So this is a simple network. There is only a LAN and firewall and the internet, right? So I'm gonna create the firewall rules in the spreadsheet, and then we'll write the rule that's equivalent to each policy to the right, and then we'll see if we can enhance or we can avoid common problems. Here we go. I typed the major elements of rule, and I'm just gonna make it a little bit bigger so that you can see it clearly. So we have the rule number, the protocol, the source IP address, destination IP address, destination port, and action. In most cases, we don't really need the source port, because, as I said before, when the host establish a connection with any remote node, usually the destination port is determined, the source port is selected random by the operating system. So we'll start by looking at each policy here and write the equivalent rule for it. Right? That's not usually or not always the way we do it, but in this case it will work because we have simple set of rules. In general, you have to look at the whole policy and design your rule set based on the whole policy rather than just looking at line by line. But for this particular example, it's simple enough that we can just translate each policy to a rule. Okay, all telnet traffic from a specified external network, it's not shown here, but it's 16.16.16, is allowed to the internal network. Okay, so we'll start by telnet is a TCP protocol, right? Or works on top of TCP. So the protocol we can specify TCP. The protocols here allowed are usually TCP, UDP, ICMP, or IP. If I say IP, or any. So if I say IP, that applies TCP and UDP as well, because anything on top of IP will have an IP header. So the rule will allow all IP headers. Just to let you know. So if you see something like this, it means that all protocols on top of your IP will be allowed as well. So TCP is an application protocol that works on top of TCP. We are supposed to allow all telnet traffic from the specified network, so that's 16. The source will be 16.16.16.0/24. The destination IP will be our internal network, which is here, 192.168.10.0/24. So all hosts on the remote network will be allowed to go to all hosts in the internal network. The destination port for telnet is 23. Sometimes you don't remember all the port number, so you just write telnet. Right? So it's either way, it's fine. The action is permit. We'll use permit deny in this tutorial. Okay, so this is our rule set. I'll make this a little bit bigger here. You can see it. Okay, so that's our first rule. Second rule, allow HTTP traffic from the internal hosts to the internet. Right. Again, HTTP works on top of TCP, so the protocol will be TCP. The source in this case is 192.168.10.0/24. The destination, we don't know what the destination is, so it can go anywhere, so we're gonna just say any in this case. And the port is for HTTP common is 80, but I'm gonna write HTTP here. And the action is permit. And finally, we want to prevent any attempt by an outside source to masquerade as an internal host. So what does that mean? It means that I don't want somebody from the internet here to have a source IP address of 192.168.10.0 and coming from the outside inside, so it pretends that it is a local host. So in this case, I'm gonna say, well, any, so that's the protocol, and the source will be 192.168.10.0. And by the way, notice that I ignored NAT here and everything, so this is not a realistic scenario because the 192.168, it's private network. It's not supposed to appear on the internet. but I'm just gonna ignore this fact for now, just for simplicity's sake. Deny, right? So it means that I am denying any traffic from the host on this network to another host on this network. Somebody would say, wait a minute, does this mean that H1 cannot talk to H2 or H1 cannot talk to S1 here? It doesn't make sense, right? No, actually, notice that any traffic local will not pass through the firewall, will stay local, right? So the only case that traffic will pass through the firewall if there is either a local host trying to talk to another local host outside with the same address, or what we want to prevent, which is an outside host pretending to be inside an inside host by using the same address. In both cases, this is not allowed, right? So any traffic that will pass through the firewall with these two with the source and IP address of the same network will not be allowed. Normally, the local traffic will not pass through the firewall, so we're good. All right. So we're just gonna number the rules here. Now, if you look at these rules, you will see that um, they satisfy the policies. We'll make sure that we don't have any anomalies. Right? So, what are the anomalies? The shadowing, correlation, and um, generalization all have to have um, different actions. And the redundancy, they have to have the same action. So let's see, these two have the same action. Are they redundant? Well, for redundancy, we have to have one matching or superset of the other, and these two lines are not neither matching nor one is superset of the other, right? For these two, permit and deny, there are different actions. So is there any correlation? Well, correlation happen if one um, rule is in one element, it's superset of the other element of the second rule, and vice versa. Okay, so in this case, we have um, um, correlation here. Why? Because we have TCP here, we have any here. So any is a superset of the TCP. We have any here, and we have a specific network here. So we have this one is a superset. So we have the conditions of the correlation. Well, in the case of the conditions of the correlation, we have to make sure that the order is correct, right? So let's see. If a packet comes trying to go from the local network to the outside, it will match this one first, right? And it will be permitted. But if it's coming from 192.10 and going to another 192.168.10, it will match this one as well. So it will not match this deny. It will match this for at least for the HTTP. So this order allows a network, a masquerading external device, to get inside if it's HTTP, and it denies everything. So if I have to make sure that this order is reversed, in this case, now I make sure that any traffic from these two source and destination addresses, any traffic whatsoever, it's denied, right? Traffic from this host, from this network 192.168, it can go outside if it carries HTTP. Alright, so that's makes sense, right? So you have to be careful about this. So that's a good example of correlation, and the order has an effect here. Another thing that I can look for is making sure that the most specific address is coming, or the most specific rule comes at the top. In this case, this is the most specific because it doesn't have any in it, right? So it's very specific, so that's okay. This is less because it has any, and this is also has any. So, and the order of these two should be this way, right? So that's the answer to this question, and it shows me that we have to look at these anomalies and be careful that we don't create an anomaly when we create the rules. All right, so this is a good example and a simple example. Let's move on to the next one. The next one, which is Q4, I'm going to ignore the others here because they don't have any relation to rules. Question 4, write, let's make it bigger a little bit. Write the firewall packet filtering rules that match or that implement the following policies for firewall F1 and F2, right? And we have a set of policies here, right? And the question is based on this network. If you look closely, there's a demilitarized zone, DMZ here, database LAN, private LAN. So there is a demilitarized zone sandwiched between two firewalls. So this is the two firewall architecture that we talked about. And these database and private LANs are protected behind the second firewall. Right? So again, we want to assume that all traffic, established traffic, can return traffic can go, so we don't have to specify a particular rule for it. And also there is a deny all rule implied, right? Just to remind you, this means that what I mean by the return traffic, when the traffic goes from let's say 16.16.16 to this to a host in 192.168, the return traffic is implied to let it or to pass, right? So I don't have to create another rule with the opposite direction here. So I don't have to create a rule with an opposite direction. Right? So that's what it means by return traffic is allowed. All right. So let's answer question number 2. We'll do the same thing here. Now we have two firewalls to deal with, right? And not all policies apply to all firewalls. For example, all traffic from the private LAN is allowed to the internet. So this means that traffic from the private LAN here has to go through F2 and then pass through DMZ and go to F1. So we need to allow it in both firewalls. The second rule here, only HTTP and SMTP traffic is allowed from the internet to the web server. So this means traffic coming from here, from the internet, going to the DMZ has to pass through firewall number 1, but it has nothing to do with firewall number 2. It's not going to pass through firewall number 2. So in this case, we need to create two rule sets, one for F1 and one for F2. So let's make sure that we have this. So this is for F1, and so when we go, let's go rule by rule as we did before, and then fix any problems later. So all traffic from the private LAN is allowed to the internet. So the private LAN is 192.168.30.0/24. So it will go through F2 here, then go through F1. So I need to create a rule at F1 that says The protocol is any, because all traffic is allowed, so I'm going to say any. The source IP is 192.168.30.0/24. The destination is going to go to the internet, so really any destination, so it's any. And the port also, the policy did not specify any particular protocol or application, so I'm going to say any as well, and the action is permit. Sometimes we use allow and deny, so I'm just using permit here. All right. Then we have the second rule, second policy. Only HTTP and SMTP traffic is allowed from the internet to the web server and email server. So traffic coming from the internet going through these two servers here will go through F1. So the protocol for both of them is TCP. The source can be any, because we don't know where it's coming, but the destination is always 192.168.10. Notice that the HTTP server has the address 10, and the destination port for HTTP will be 80, and we will permit it. And another rule for the second server, SMTP server. SMTP is an email server, so with the address 20, and SMTP, I think it's 25, but we can just write SMTP and just keep HTTP here just for consistency. Okay, so I allowed these two. By the way, I can say deny everything else, so any anything coming to this network deny. So this is literally translates the policy only HTTP and SMTP traffic is allowed, right? So any traffic coming from here will go here. It has to. It's going to be denied unless it's HTTP or SMTP. All right. Third policy: all traffic from the private LAN is allowed to all DMZ servers. So the private LAN will. So that has nothing to do with F1 because the private LAN will go through F2. So it's not related to F1. So I'm going to skip it. Let's see the next one. Only traffic from the contractor network to TCP port 1443 in the database network is allowed. So traffic from the contractor can go all the way to the database, right? So it has to go through F1, right? So I need to make sure that it can go to F1, can go through F1 by creating a policy. The contractor has a address 134.173.23.0/24. So we are allowing the whole network there to go to the destination. The destination is 20 here, 192.168.20.0/24. And the particular port that's allowed is 1443, and we will do permit. And well, that's it. So let's move to the next one. TCP port 14 traffic from the private LAN to the database is allowed. So this is passing through F2, so it is not relevant to F1. Okay, HTTP and SMTP traffic is allowed from the private LAN to the web server. Also, this is not relevant to F1 because we are passing through F2 here. SSH traffic is allowed from the private LAN to the database. Also not allowed, not relevant to F1. So these are the only things that are relevant to F1, the first firewall. All right. So again, we need to make sure that there are no anomalies, and then make sure also that everything is sorted properly. Right. Okay, so if you look at, before I do anything else, let's assume for a second that we have a explicit deny all, right? So we'll just add another deny all rule at the end, just to make sure to emphasize something. If I do deny all and make it explicit here, redundancy happens when you have two rules with the same action, and one rule is a superset or matching the other rule. So in this case, you have this rule, rule number 6, and this rule number 4. I'm just going to highlight them here. These two rules, the sixth one is a superset of the fourth one. This is implied, of course, but still remains a superset of rule number 4. So if I delete this one, nothing will happen. Let me show this again. Right? The packet that matches this one will also match this one. So if I remove line 4, the packet will match the number 6, or the implied rule. Right? Now you have to be careful. That's not always the case. I am being aware of the middle one here, so I'm sure that it doesn't match this one. You have to make sure that these two, right? They're not. So if the packet does not match number 4, it's not going to match number 5 because the destination is not the same. Right? So there's no case where it will match number 4, and if I remove number 4, it will match number 5. No, it doesn't happen. So I can safely delete this one, right? And nothing will happen. So I save myself a rule, and making the same policies will still be implemented, right? So a packet that comes from the internet to this network, to the DMZ network, it will match either rule number 2 if it's HTTP, or it will match rule number 3 if it's SMTP. It will not match number 4 because the destination is not the same. So eventually it will be dropped if it's not HTTP and SMTP. Right? I keep repeating this multiple times so that you really get this point. So okay, I made sure that I removed an unnecessary rule here. Remaining rules are all same action, so there is no possibility of correlation or generalization or shadowing, because these three anomalies, they have to have different actions. These are all same actions, and we saw that there is no redundancy. The only possibility here for redundancy, but we don't see any redundancy, right? So they are all distinct. Okay, so that looks good. The only thing that I'm gonna change here is making sure that I follow the rules by saying any specific the specific rules have to be at the top, just for performance usually. So this one here, it's the most specific because it has a specific protocol, specific source IP, destination port, and permit. So it should be at the top, right? So I can move it at the top. Let's see, we'll move this here. I can even, this is the least specific, so I can move it at the bottom. In this case, sometimes just the performance issues. It doesn't necessarily make any big difference for rule set because there are just 4 rules, so the impact on performance is small. But in a large rule set, you want to make sure that the more specific the rule is, the faster it matches and goes away, right? Alright, so that's the rules for F1. So we're gonna do the same process here, go over the same policies again, but we'll implement the rules that are relevant to F2. Okay, let me copy this, change this to F2 here. Okay, so let's revisit all policies from the top. All traffic from the private LAN is allowed to the internet. So the traffic from the private LAN has to go this way to go to the internet. So we need a rule at F2 here. That will be same as this one here. I'm just gonna copy it as is because it's the same policy. And only HTTP and SMTP traffic is allowed from the internet to the web server. This has nothing to do with F2, so we're going to skip. All traffic from the private LAN is allowed to all DMZ servers. So that's relevant to F2. So it says that all traffic, any, from the private LAN, which is same as this one here, is allowed to the all DMZ servers, so 192.168.10.0/24, and the destination port is any because we don't have any specific, everything should go, so that's also permit. Alright, next. Only traffic from the contractor network to TCP port 1443 in the database network is allowed. So this traffic will go from the contractor, will go to through F1 and then to F2. This is the same one as this. So I'm just going to copy it here. It's going to do the same job. TCP traffic going from 134 will go to this network here. Okay, let's move on to the next one. TCP port 1443 traffic from the private LAN to the database network is allowed. So it's almost the same rule as this, but in this case the source is coming from the private LAN. So we need to make sure that the source IP is from the private LAN. And the second to last rule or policy says HTTP and SMTP traffic is allowed from the private LAN to the web server. So the traffic will go this way, and it will pass through the firewall number 2. So we need to create so practically these 2 rules here are copied here, but the source is the private LAN instead of just just the external network or the contractor. And finally, SSH traffic is allowed from the private LAN to the database and the DMZ network. Alright, so SSH works on top of TCP, and the source would be 192.168.30.0/24, and because it's allowed to the database, so we're going to start with the database network first. We don't have a specified server, so I'm just going to let it go to the entire network here, which is 20. SSH is number 22, the port number 22, but I'm just gonna write SSH. And the second one is supposed to go to the DMZ, so the DMZ has address 10. Okay, so that's it. That's all the rules. Now I just want to make sure that there are no anomalies here. Okay, so the first thing I notice is that we have a rule here that says any protocol from this source can go to anywhere, right? And if you compare these and this one, they're all, just separate them for a minute, they all are redundant to the first one. Actually, a packet will never reach these because it will match the any. So TCP is subset of any. These addresses are subset of any. So they are all redundant. So if I move them or remove them, they are unneeded, unnecessary. So I'm just going to remove them without any penalty here. So the traffic, basically this one also redundant. I can remove it. All of these are redundant. I can remove them. So that's what we left with. We left with just two policies. I can make this, because it's more specific, I can put it at the top, and that's it. So I hope you got this point. So I saw that all of these specific rules are just redundant to the first rule that says all traffic from the private LAN is allowed to the internet, even though it actually does not specify the others. But if the traffic is going from the private LAN passing through F2, and it has the F2 will allow any destination, which means it will allow the destination to the database, it will allow the destination to the DMZ, and also it will allow the destination to the internet. So all of the other rules that I wrote were just not necessary. Right? So we end up with just these two rules that will satisfy all policies. Now someone would say, oh, but this is way too permissive, too many, I mean, that's a lot of any. Yes, it's true. Usually, we try to tighten this a little bit by adding another element. For this simple 6-element or 5-element rule, we don't have a way to make it more specific. But if I add direction or if I add an interface, then I can make the rules a little bit tighter. So this is what we will do in the next exercise. So in question number 5, we'll repeat the same process here, but we will add the direction, so we'll make it more strict. So in question number 5, we will add another element here. So we'll just add, this is Q5, and instead of just 5 elements here, we will add direction as well. So we'll just push this. Okay, maybe we need to tighten this a little bit so we can see the action. All right, we're gonna do the same exact thing, but this time we will introduce direction. You can introduce direction by making simple, for example, if I want to do DMZ to private LAN, so I can say DMZ to private, something like that, right? Okay, so all traffic from the private LAN is allowed to the internet. For F2, we saw this. How about this time I'm gonna write the two rules at the same time so we don't repeat the policy multiple times since you already have seen it. So we are going to create another rule set with F2, leaving enough space here for the first firewall. So all traffic from the private LAN is allowed to the internet, so it has to go through F2 first. So we'll write F2. The direction is from the private to, notice that it will go from the private to the DMZ, right? So along these two lines, two interfaces. So from the private to the DMZ, that's the direction. The protocol any, the source will be 192.168.30.0/24. The destination is any, the destination port is any, and the action is permit. Right. So that's the same, that's the traffic from the private LAN going through this interface here and exiting from the other interface toward the DMZ, and then we'll go from the DMZ to the internet. So in this in F1 we will have the same rule. We can name the direction as DMZ to internet, or we have a better way to do this by saying it's just outbound, because this particular firewall has only two interfaces, so it's either outbound from inside to outside or vice versa, right? So we'll just call it outbound. So that's the policy. The first policy. The second policy, only HTTP and SMTP traffic is allowed from the internet to the web server. So this is the traffic coming inbound. It has to be TCP. The source can be any. The destination is the we have two destinations, 192.168.10.10, which is the server, the HTTP server, and the port will be HTTP or 80, and we're going to do permit. And we're gonna double the same thing for double the or copy the rule for the other server. Just change the IP address and change the protocol, which is now SMTP. Now I learned my lesson from the last time. I'm not gonna do any deny because it's gonna be redundant, so I'm gonna keep this. All traffic from the private LAN is allowed to all DMZ servers, so private LAN traffic will go this way to the DMZ. If you noticed that this will be allowed, I already have a rule for it, so I'm not gonna repeat that again. So all traffic from the private LAN is allowed to all DMZ servers. This rule satisfies everything. Rule number 1 in F2. Okay, moving on. Only traffic from the contractor network to TCP port 1443 in the database network is allowed. Here, this traffic will go through F1 and F2. So we need two rules, one for F1, one for F2. So for F1, it's inbound. The traffic protocol is TCP, and the contractor is 133.173.23.0/24, and the destination is the database network, and the port is specified as 1443, and we will permit that. Okay, and I need to repeat this for F2, but the direction here will be from the DMZ to the database, right? So it's allowed in this direction only, so from the DMZ to the database. Moving on, TCP port 1443 traffic from the private LAN to the database network is allowed. Now notice here that this one will not work, so I have to specify the private to database TCP 192.168.3.0.0/24. The destination will be this one here, and the port is the same. Okay, now we have specific direction for this traffic, right? So it does not the rule number 1 is not enough to let the traffic go to the database because it has a specific direction. HTTP and SMTP traffic is allowed from the private LAN to the web server. Okay, well, this rule, if I create a rule, it will be PR to DMZ TCP, and this is gonna be 192.168.30/24, and then the destination of the server and HTTP, right? But immediately I recognize that this rule is redundant because this will satisfy the same thing, so I don't need to do this. SSH traffic is allowed from the private LAN to the database and the DMZ network, right? So let's see how that works. So we have from the private LAN to the database network. We create SSH is a TCP also, and we have this network here as a source, and it's allowed to the database network, so we have this as destination as well, and we have SSH, and we have permit here. Okay, so these two are not redundant because each one of them specify different destination port, so we need them both. The last one will be from the private network to the DMZ. The destination will be 10, and you know where I'm going with this, right? And this again will be redundant with this one, because still the any that it still satisfies the same conditions. So we can just remove this one. There is no need for it. Okay, now I can just make sure that there are no other anomalies and maybe sort them out properly. Again, the sorting is just a guideline for performance, and you have to be careful with sorting. You may actually create some unintended problems if you just sort them just because of sorting, right? So you have to be careful about, just don't just sort them without thinking of the consequences, right? So here I can see that there are all permit actions, so there is no possibility of 3 out of 4 or out of 5 anomalies. So the only anomaly that's possible is redundancy, and I was very careful not to create the redundancies, right, from the beginning. So I can leave it as is. I can sort it a little bit by saying, well, this is the more specific one, so I'm gonna keep it up there. So I'm gonna remove this to the bottom, move this to the top, so it becomes more, this is the more specific. The least specific actually is this, because it has any in 3 elements, so okay, I'll leave it as is. For F2, the more specific one is this. Actually, all of them, with the exception of the top one, is less specific, so I'm just going to move it down here, and that will be the order that I will leave it with. Right. Notice that this order does not change any logic, right? So it just meant for maybe performance. If you have hundreds of rules, this will be significant, but this has nothing to do with the actual logic of the rule set. And actually, if it changes the logic, if it changes the meaning, then you shouldn't do it. So you have to be careful, especially if you have a mix of permit and deny here, then you have to be very careful about changing the order, right? I'm doing it just because we have all permit here, so it doesn't really matter. Okay, let's move on to the next exercise. Let's see, do we do question 6 or question 7? Alright, how about question number 6? A company XYZ has its web browser placed in a DMZ which is protected by a network firewall. Write a firewall rule set that allows any host from the internet to access the web server using TCP port 80 or 8080. Add a rule that prevents any host on the remote network, this particular remote network, from accessing the web server. assume return traffic is permitted, and there is an implicit deny rule. All right. So let's copy one of these elements here. This is question number 6. We need to allow any host from the internet to access the web server. So protocol, first rule, the protocol can be TCP, the source is any, the destination, we are not given a specific um, IP here, so I'm just gonna call it web server, right? And the destination port will be 80, and the action will be permit. And I'm gonna repeat the same thing for port 8080. These are two common HTTP ports. The last one, I need to prevent a specific network from accessing the web servers, right? So let's play along here and pretend that we don't know what we're doing, right? So I'll add just another rule that says any, and the source will be 129.173.143.0/24, and the destination is the web server. So we want to prevent any traffic from that particular network, right? So that's why we'll do deny. Right? Now immediately you will notice a problem. The problem is we have I think probably correlation issue. So we have permit and deny. So that means two different actions. This is a specific content here. This is more general, so this is a subset. Rule number 2 is a subset of rule number 3 in the destination port. The opposite is true in the source IP. Any here, which is a superset of this address. Again, it could be more elements, so you see here that this is more specific than this any. So here the order is very important. I'll give you an example. Let's say a port, an actual traffic coming from this network that carries TCP with the destination port 8080, it checks the first rule, does not apply. It checks the second rule, it matches. So it permits, so it goes. It's allowed. While the policy here says that you shouldn't allow any traffic from this host. So this order is wrong. I have to fix it. Now these two rules are the same, so I have to fix it by putting this at the top. Now everything is okay. Now everything is good. Because if any traffic going to the web server with any protocol, it doesn't matter what it is, it will be caught by or match by the first rule, and it will be denied first. And then anybody else with these two ports and protocol TCP will be permitted, right? So this is another example of order is important. The order of the the order of the rules is important. All right, so I hope that's a good example for this case. Uh, Question 7. Let's see. The table below In the table below, you see a firewall configuration for the network topology shown below. The firewall configuration is flawed, it has problems. Find 4 mistakes, or probably 3 mistakes, that lead to a behavior that's probably undesired. I think it will be 3 because we have 3 rules. So it will be three problems, maybe just a typo. So let's look at it one by one. The first rule A says from zone 1 to any with the TCP protocol, allow any source, any destination, any destination port. That allows traffic to go through the firewall to the internet, through the firewall to zone 2, so it's fine. So the only problem here is that this is too permissive. Right? If I know that in zone 1 all hosts will be 192.168.1, so why make it any? If I make it any, this invites people to probably just change IP addresses, masquerade, create problems. So I better not to make it too permissive. And we talked in the lecture about having too permissive, excessively permissive rules. So this is a good example of maybe changing the rule a little bit to make it less open, less permissive. Better specify the address, we'll put it here instead of any, right? So that's the problem with A, rule A, that there is no need to make it wide open and say any. And that prevents any spoofing. If somebody comes to zone 1, change their IP address to anything they want, they may bypass one of these rules. So a good security practice is to specify as much as possible, right? So we will replace this any in the source IP with the specific IP address. All right, if we move to B, we see there is any to any in the direction, the protocol is any, and the source is specified. If you look closely, again, there is a possibility of masquerading here. How? Well, if somebody on the internet sets this IP address 131.159.20.0, they will be able to bypass the firewall. They are outside, they can go send traffic to the zone 1, and the firewall will allow them because the direction is not specified here, just specified any to any. So they will be allowed. So there is no need for any. We can specify it, replace this by zone 2 to zone 1. So that will make it more strict. Finally, C. What's wrong with C? If you notice, C shares a lot of details with A. The actions are different. One is permit, one is deny. But A is a superset of C. A has the same direction, same protocol, same source IP, same destination IP. The only difference is the destination port. This one says any, this one says 22. So this means that actually, because of the shadowing problem, C will never be reached. any packet that has the destination port 22, it will match A and it will be permitted, while in fact we want it to be denied, right? So in this case, C, to make sure that it's any traffic for destination port 22 is denied, we have to move it to the top. We have to move it to the top of A, right? So if you are wondering, okay, is this redundancy? No, there is a difference. The redundancy, the action is the same, while one rule is a superset of the other rule or match the other rule. With if the action is different, then we can have either generalization or shadowing. Generalization, usually it's a good thing, it's not a bad thing. Generalization, when the top rule is more specific than the bottom rule. That's generalization. Shadowing, when the top rule is more general or superset of the bottom rule. In this case, we have shadowing. So we need to move this to the top. So what we will do here is rewrite these and in the right order and make them correct. So question number 7, we can copy these because they have direction here. Okay, rule number 1 or no, rule number A. In this case, I'll move zone 1. I just type Z1 here to any and TCP any destination port is 22 and deny. So that will eliminate shadowing. B will be zone 1 to any TCP, almost the same thing except that it's all the action is permit. Sorry, I'm having difficulty typing here. C is zone 1. B, actually, we said that the C, which will be from zone 2 to zone 1. Yeah. And also, I think I said that we need to make this more specific, right? So this one should be more specific. So 192.168 10/24, and this also following the same rule. It has to be more specific. And finally, instead of any, we will specify the rules, the direction from Z2 to Z1. The protocol is any, and the IP address is 131.159.20.0/24, and I'm just going to copy this one instead of typing it. Alright, let's check this out, make sure that everything is okay. So in the the rule number C originally moved up, became rule number A. The original rule number A, we said that we were going to make the source IP more specific, so that's more specific here. And we applied the same rule because it's coming from zone 1 to any, so again this one also more specific. And instead of any to any direction, I made it more specific, zone 2 to zone 1, all of this so that we can eliminate masquerading and shadowing. Okay, so that looks okay. Yeah, I think that's all that we need to change. Yeah, that's it. Okay, how about question number 8? It's the last one in this series. So question number 8. Let's look at it. You want to configure a firewall for your network. The figure above, so we're going to use the same network here. The figure above shows the configuration you want to achieve. In zone 2, there is a web server, which has the address 1 here, on TCP ports 80 and 443, and one email server, which is .2 here, on TCP port 25. Your users reside on zone 1. Your security policy is as follows. Your local users may freely access any web service anywhere on ports 80 and 443, i.e. they are allowed to browse the web. None outside zone 1 can initiate connections to zone 1 on any port. Okay, so traffic from the outside zone 1 cannot send anything to zone 1. Then in the second rule or policy, everyone including the internet can access web server both ports, so 80 and 443, and email server in zone 2. However, no host on zone 2 can initiate connections anywhere else. And finally, local users can access the web servers and email servers in zone 2 via SSH also. Assume stateful firewall configuration for the given scenario, and there is an implied deny all rule at the end of each rule set. Okay, so as we did before, let's take it one policy at a time and write the rules for it. We'll use direction here. It doesn't specify that you use directions, but I'm going to use it. Okay, so the first policy says your local users may freely access any web service anywhere on ports 80 and 443. Notice that web servers are located either on the internet or there is a web server in zone 2 as well. Right? So I'm gonna write zone 2, the direction to, let's call it to internet, and the protocol here is TCP. Excuse me. The source is 192.168.1.0/24. The destination IP, initially I can say any, right, for the internet. Destination port is 80, and the action is permit. And since we have 2 ports for web services, so I am going to double this and change this to 443. By the way, 443 is the HTTPS, right? The secure version of HTTP. Then I can do the same thing, but from zone 1 to zone 2. I'm going to copy this and make sure that I have a specific IP address for the destination this time, which is the first, so it's 131.159.20.1, and so that's very specific. Okay, that satisfies, almost satisfies policy number 1. We just need to, there is another sentence there that says, none outside zone 1 can initiate connections to zone 1 on any port, right? So nobody from anywhere can go to zone 1. So I'm copying the fields here. Okay, so zone 2 cannot initiate traffic to zone 1. Internet cannot initiate traffic to zone 1, right? So that's what it means by none outside zone 1 can initiate connections to zone 1 on any port. So that's satisfied. Let's move on to policy number 2. Everyone, including the internet, can access the web server, both ports, and email server on zone 2. However, no host on zone 2 can initiate connections anywhere else. Right. So let's do that. So from the internet, going to zone 2, traffic TCP, source can be any because we don't know where it's coming from. The destination has to be for the web server, these two, and I just need to duplicate everything in here. And we also have another server. The server is 2, and the works on port 25, written here as port 25. Okay, so now I am allowing everyone, including the internet, can access. Okay. However, no host on zone 2 can initiate connections anywhere else. So zone 2 to any just remove this, replace it with 0/24 any deny. So that's the second policy. The third policy, local users can access the web servers and email servers on zone 2 via SSH. SSH port 22, by the way. So local users, this means zone 1, can go to the web server and email server to zone 2. So that's zone 2, TCP. The destination is this one. Oh, it's the source. The destination is actually this one. Yes, true, but different field. The source will be this one, S22 and permit. Yeah. So that's the conclusion of all the policies. Now again, I want to make sure that I don't have any anomalies, redundancies, and such. So let's take a look. Again, I'm going to use the same technique I did before and just number the rules first so that I can describe them to you. So I'm going to add what's supposed to be the implicit deny all, but I'm going to specify it here. So any to any here, any here, any here, any deny. Right. Now, if you look at all of these rules, you see that rule number 5 denies any traffic from to zone 1. And if you look at it, you will see that these two have the same action. This is a superset of this. So if I remove this, nothing will change. Same thing with this one, number 9. So I can remove them. Again, you have to be careful that there's nothing in the middle here that changed the logic, right? So if we deny this, nothing else will be affected. It seems to me that if I remove these two, there will be no ill effect here. Right? So I don't need to deny those because they're going to be implicitly denied later by the last implied deny all rule. Okay. Anything else I can do to improve, or they're all permit here? So is there any possibility of redundancies? We'll see here these two, they're not redundant because they have different ports and same direction, same everything, but different ports. These two, same thing, so they're not redundant. These three, they are distinct. Alright, so it looks like we don't have any problem with redundancies here. We'll see that, this is the more specific one. Number 10 here is the most specific. Let me change the order again. So I can move it at the top. Not necessary, as I said, just maybe out of habit. It is the more specific because it doesn't have any any's. This one is also specific, so I can move it. And also makes it nice that all of these are related to the same direction, so make it more organized. Alright, so that looks okay to me. So that is the conclusion of this tutorial. I hope this was useful and gives you an idea about how to design firewall rules for different scenarios. Scenarios can get a little bit more complicated by creating more rules and more exceptions. In most of these scenarios, we don't have a lot of exceptions. But sometimes you see permit deny generalization being used, especially if you want to allow one host out of the network, but deny everything else, right? Or one protocol, but deny all others. So in this case, you will find that there are denies and permits interchanged or intermixed in the rule set. So maybe in another more advanced tutorial, we look into this. For now, thank you for listening and watching this, and we'll meet in another recording.